here for you. See, I forget one. I have it. Vm exponential of j theta, rim exponential of j phi. You change this to this one. This is phasor voltage. This is phasor current. Correct? For the resistors, your phasor voltage is I times R. Because remember, why is that? I will rewrite for you here. What is the V of t in a time domain? Is R I of t, correct? But you saw that time domain, you put V of t, this for function, which I'm going to put it. This is better way you see. J omega t plus theta. R, instead of I of t, you put what? I exponential of j omega t plus phi, correct? If this is a source, this is a current in general for resistor. Voltage across resistors is R times I. So what you did here, you cancel exponential of j omega t. So what you got is Vm exponential of j theta is R Im exponential of j phi. What is this one? Phasor voltage is R phasor current, correct? So the angle of the voltage is the same as the angle of the current. That's why we say current and voltage are in phase. Current and voltage across R are in phase. So I want you to write these things. If you, this part is better way to show you. So add it to your note, or are you guys print your note and or you doing your iPad make changes? Yes or no?
Yes.
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 Yeah, please do that because when I teach in the class, but I didn't want to write all of these things one more time on paper for you because you have the note, you just listen to me, it's much faster, and we have time to do some homework problem later, correct? So we're saving time, which is better than teaching on the classboard, everything on the board, and you keep just writing, you don't listen to me. Okay, so but maybe this part is the same thing here, but maybe that is the voltage across resistors is R times I. Instead of the voltage, you put the complex forms, complex exponential of j omega t cancel from both sides. You have this. This is phasor voltage. That is phasor what? Current. So for the resistors doesn't change. If I do in a time domain, voltage is R times I, and phasor domain, voltage is R times phasor current. And you see that the angle here is exponential of j theta. When I equate them, these two angles should be the same. So the voltage and current across the resistors have the same phase angle. That's why we say they are in phase. The voltage and current across are. Okay. But what happened for, let's just do one example here, and then you will see. So it doesn't matter for the resistors alone to do in a time domain or frequency domain. I don't save any time. But for inductors and capacitor, you're going to see you save that. Imagine that you have a 2 ohm resistors and they give you this voltage, V of t, and they ask you to get current. Okay, you know the current is voltage divided by resistor. So 4 divided by 2, you get this, correct? Now, if I change the sign to cosine, you subtract 90 degrees. So you come with this. So what is the phasor current if I change this now? It's 2 angle 135, correct? Because I cannot directly go sine to phasor current. You need to change to cosine. Okay, if I want to do phasor domain analysis, from beginning, you change this to phasor voltage. You subtract 90, you come with this. the resistors is 2, you get the same answer, correct? So it doesn't matter either. From beginning, you change this to phasor. How we change this to phasor? You subtract 90, so you come with the angle. So that's my phasor voltage divided by 2. So if I do analysis in a time domain or phasor domain, you get the same answer. So no saving in time or effort in any way for the resistors, okay? But your circuit doesn't have just the resistors, have inductors and capacitors, correct? So let's see what happened for the inductors. Okay, if I have the inductors, you know the voltage across inductors is what? Derivatives of the current, correct? If I give you the current, to get the voltage in a time domain, I have to calculate derivatives. So that's why I go to complex. Okay, remember the voltage, always I use Vm exponential of j omega, current Im exponential of j omega t plus phi, correct? They're equivalent complex, always. So you say it's V of t. In all my derivation, I use this general form. This is my voltage. This is my current in a complex form. The real part of them is a real one. Okay. So in this equation, instead of voltage, you put this. Instead of the current, I put this. I calculate the derivatives is a j omega times the exponential, correct? Then I come, these two terms, suppress exponential of j omega t or cancel it. So you come Vm exponential of j theta is j L omega Im exponential of j phi, correct? Now, what is a j equal? Remember last time I told you j is like j90, correct? Do you remember this? Or j pi over 2, doesn't matter. Wherever you have j, like 90-degree phase difference. Why? Because if I expand this, this is cosine of 90 plus j sine of 90. Cosine of 90 is 0, sine of 90 is 1. So the number j is at like 90-degree phase. Or wherever is a j, you can write it as an exponential of this. So that's why I get rid of the j here, and instead of j, I put this. Is that clear? Any question here? Are we doing okay? Please answer me.
I think we're doing good.
Okay, you are the only one answering. The other is, I don't know where they're. Okay, so you have L omega Im. So when you multiply two exponential, you are adding power, correct? Okay. Why are you doing these things now? One is that because I show you that theta here, when you equate these two together, you have the real Vm magnitude, the Vm magnitude is here, is L omega M. But the angle theta is phi plus phi over 2. See, the phase angle here is theta. Phase angle here is phi plus pi over 2. So the phase angle difference between voltage and current between these two is what? Pi over 2. So inductors add 90-degree phase difference between voltage and current. Now, let's go back to this part. Again to this part without change. This is your phasor voltage. This is your phasor current. So your phasor voltage for inductors is J L omega phasor current, correct? So maybe this way is easier instead of this. Any way you want to see. I told you Instead of J, you can put what? 90 degree. Oh. So if I divide V to the I, what you get? J L omega, correct? So you have L omega, instead of J, you put 90. Or I can write here like this, L omega I. Instead of J, you just add 90 degree. So whatever is the angle of the current, you added 90. One more time, I go through it. What this one is telling, the voltage and current across the inductors are out of the phase. What are the phase angle difference between them? Is 90 degree because of this J. Is that correct? So one more time, I go through it. I want you all get it because almost we will done with most of the analysis here. But these are the basics. Okay, remember when I says from the previous pages, when you have the cosine and cosine voltage and current, we write complex equivalent of them, correct? So instead of voltage, we're doing complex domain. You put this, instead of current, we put this, correct? Now, for the inductors, we know voltage is derivatives of the current. So I substitute voltage and current here in a complex domain. You calculate derivatives, they come with this equation. Then I suppress or cancel exponential of j omega t from both sides. So you come here, the left is Vm exponential of j theta, right is j L omega, Im exponential of j phi. So I do two ways. Let's jump from here to here. This is your phasor voltage. Im exponential of j phi is phasor current. So the phasor voltage across inductors is j L omega I. See what happened here. Time domain, voltage current relation is derivatives, correct? For inductor. Here, when we do the complex or phasor, is a product, no more derivatives. Is that right? So from the derivatives, we switch to algebraic equation. The only weak point is you need to know complex. Okay. Now, I was telling here that J is 90 degree. Instead of J, you always can put 90 degree. That's fast way. If you, because of the Euler identity. So you can either go through this way or this way. That's faster later on if you know. But I will go a slow one also. Instead of j, I put the exponential of j pi over 2. You multiply them, you get this. So what that, when I equate these two, your phase angle theta is phi plus pi over 2, or phase angle difference between voltage and current is pi over 2. Same thing here. Phase angle difference between voltage and current is pi over 2, 90 degree. So theta minus phi across inductors is 90 degree. So that's why it says the current lag the voltage across L, because we are on the L, by 90 degree. Or the inductors called lagging element. When they say inductors is lagging, it means current lag voltage. Current lag voltage by pi over 2. So whatever is the phase angle of the voltage, you subtract 90 degree to get what? Phase angle of the current. Or whatever is the angle of the current, you add 90 degree to get the voltage. Okay, so my equation for inductors is changed to this, J L omega I. So instead of doing derivatives, you just do like this. Is that clear? Okay. Now, when we do the analysis in a time in phasor form Okay, imagine now I want to get my current. So what is your current here? V divided by JL omega. Current is V divided by JL omega. So whatever is current, Vm theta, instead of J, because noise goes to the denominator, numerator when you multiplying by J, you subtract 90, correct? So now this is your phasor current. What is my real current? The real part of this. So you write the real part of VML omega exponential. So you write VML omega cosine of omega t. This is the angle. So I can do numerically. If you don't have any question, let's just show with the example what you're going to do. See, imagine they give you voltage. Okay, so you got the voltage, and there is an inductor, I of t. So this is your voltage V is given, and the current I, and the inductor is 4 Henry. Okay, if I ask you to get the current in time domain, what you need to do? Integrate it, no? Because VL is L di to dt, or I is 1 over L integral of the voltage. So if I want to get time domain, I need to integrate. But what you do in the phasor, you say you change the voltage to phasor voltage, correct? From previous page, you saw that VL is JL omega I. That's the only thing you need to know. Algebraic relation, correct? So what is the I? V divided by JL omega. You change voltage to phasor. Okay. This is a cosine, which is okay. It is positive, is okay. The angle is what? Negative 50. So it's 8 negative 50, the phasor voltage. You write L, J, L, omega. What is my omega? 100. This is your omega. So you substitute here. Omega is 100. L is 4. Instead of J, what you do here, you can also write as 400 angle 90, correct? So when you subtract them, what the angle is gone. Or you can bring J to numerator, doesn't matter. So basically you have 8 minus 50 divided by 490. So you just divide these two complex numbers. So 8 divided by 400 is 0.02. You subtract these two numbers. 100 phase angle minus 140. Now, this is phasor current. What is my real current? You change this back to this. It's 0.02 cosine of 100t minus 140. Correct? So you don't need to integrate. I wait here to see if you get that. Any question on this? Are you?
So, so inductors are always out of phase by 90 degrees?
Yes, inductors and current and voltage always by 90 degrees. Just inductors alone, okay? We're doing one by one. Always is that. Why is that? Because the voltage across inductors is JL omega times current. And what is J? 90 degree, correct? So whatever is angle of the current, you added 90 degree to get angle of voltage. Or whatever angle of the voltage, you subtract 90 degree to get angle of current. Why I subtract? Because J comes to denominator. So voltage and current across inductors are out of phase by 90 degree. Current always lags the voltage. That's what we say in engineering. Okay, the phase angle difference between these two are 90. Whatever is angle of the current, You added 90 to get angle of voltage. See, here, time domain, you need to integrate. But here we just do what? Multiplication or divide. Okay? So what you need to know is this equation. Voltage of the inductors is JL omega I. Memorize this now. For resistors, it's just RI. Doesn't matter. That's why, because there is no J here. Whatever is the angle of the current is the same as the angle of voltage. Okay. We do the same derivation for capacitors. See what happened for capacitors. We know that the current of capacitors is C dV to dt. Okay. Instead of the current, again, you're going to put what? Im exponential of j omega plus v. Instead of the voltage, you put what? Vm exponential of j omega. Always in my derivation, I put this for voltage, this for current. Okay. So now you go for capacitor, current is derivatives of the voltage. Okay, we calculate the derivatives of this one. I didn't write for you, so let's just write it this. You write Im exponential add, if you want to see it, is. What is the derivatives here? Is j omega c Vm exponential of j omega t plus theta, correct? Okay, you cancel exponential of j omega t. Here is Im exponential of j phi. Here you have j omega c Vm exponential of j theta, correct? Instead of j, I put what? 90 degree. So you can write say, or you go very faster like this. This is my phasor current. This is the phasor voltage, correct? So what is the current through capacitor? Is J omega C phasor voltage of the capacitor. Or voltage is current divided by J omega C. Phasor voltage for capacitor is a current divided by J omega C. Instead of J, you put 90. So here, the phase angle difference still is 90. See, your theta is equal to what? I'm sorry, your phi is equal to what? Your phi here is theta plus 90. Or theta minus phi is negative 90. For inductor was plus 90, the theta minus phi. So the phase angle difference still is 90, but these times the current lead the voltage by 90. See, whatever is the angle of voltage, you add 90 to get the angle of current. For the inductors, whatever was the angle of voltage, you subtract 90 to get the angle of the current, correct? Angle of the current, I'm sorry, you added here to get the angle of the voltage. Here, whatever is angle of the current, you subtract 90 to get the angle of voltage. So they are still out of phase by 90 degrees, but the current leading the voltage. Over there, the current lags the voltage. So what you need to learn here, the phasor voltage for capacitor is the current divided by J omega C. Or you can multiply numerator and denominator with J. So you have Ji, J times J, or J square omega C. What is J square? Negative 1. So that's why you can write negative Ji over omega C. Negative J is equal to what? I omega C negative 90. That's why you get here. Okay, I wait here if you see any question. So what I need to memorize, know is this for capacitor. That instead of the derivatives or integrating the current to get a voltage, you just divide the phasor current to j omega c. So your integral differential equation again changed to numerical equation. Okay, any question here? So we do analysis after this, always using what? Phasor. You know, now I have the whole class, but some of you come late. On the class, I know who is late. Here also, I can figure out who is entering late, but I don't want it to bother myself. But and to take the class time to go look at the participant. But for your benefit, to start Zoom from early, like instead of coming 10, 15 minutes late, you miss the lecture. So it's kind of, maybe you get confused. So start, some of the students I see even 1 hour, 2 hours before they go to the Zoom, which they are very early. Thank you. But at least 5 minutes before class start your Zoom. Wherever you are, come earlier because you're missing the class time and you miss lots of lecture. So one person come now. So what is the benefit? Are you going to follow me? No. You can't because you miss the important part. It is all of these things is really, I will say, it's not I don't want to be mother, not I don't want to control you. I just care about you. I want you to learn that subject. 10 minutes make difference. You were lost in the class. Okay, so let's do the example. So imagine you give you the capacitors. You have 4 millihenry, millifarad. Oops, I always don't know how to this. I have to learn and I forget. Sorry, just wait. All of this phone to my home is just advertising. And the reason I keep my home because of security. So that's why I never answer. Okay, see, I give you the voltage across this, correct? And they ask you find current. If you want to do it in a time domain, remember what you need to do. Current, you need current of the capacitor is what? C dV to dt. You need to calculate the derivatives, correct? And I did it here for you. C dV to dt, and then you know how to calculate, you come with this answer. Okay, but what we do in frequency domain or phasor, same thing, phasor. You will know that phasor current for capacitor is j omega CB because last time I showed you this is current divided by what? J omega C. Or current is the product of these two. V times j omega c. Okay, so you change this V to phasor voltage. What is a phasor voltage equivalent to this? Is 8 with the angle 50, correct? So you come here, you say J, omega is 100, C is what? 4 millifarad. So this is 10 power of minus 3. Sorry, not 100, minus 3. 10 minus 3. So you put here 8, 10 minus 3. The angle for the V is what? Negative 50. Instead of J, you added 90 degree. Correct? So if I want to do this correctly again, I says my IC is J omega C voltage. Okay. Your omega is 100. C is, what was it? Where is it? 4, 4. 4 times 10 power of minus 3. That's your C. Then V is what? Phasor voltage, I change it, is 8 with the angle negative 50. Instead of J, I added 90 here. You don't need even to write. So you multiply them together, you get 3.240. Same answer here. This is phasor current. So how much is my real? Now you change back to the real. It's 3.2 cosine omega, which is 100 never change, plus 40. Same answer. So we do analysis in a phasor. Okay, any question in this example? Are we doing okay? Unless I read the chat, sorry. Oh, what was phasor voltage resistance? Okay, some of the question in the chat is that we do one is that most of you, the answer is here. Okay, one more time. This is a review of what I did. So you don't need to, if you want, you can read the revision. I don't ask the revision, okay. These are resistors, inductors, capacitors. Most of the question you ask on the chat, I will answer here. Okay, time domain, we know this equation, correct? Voltage across resistors is R times I. Across inductors is LDI to dt. Across capacitors is integral, okay? Now, phasor or frequency domain or phasors, which is better name, voltage across resistors is R times I. So whatever is the angle of the current, they are remain the same for voltage. So if I show the voltage angle with theta and current angle with the phi, they are always the same, correct? So no phase difference, no phase difference, voltage across, voltage and current, between voltage and current across resistance. For inductors, this J is equal to 90. So the angle of the voltage is angle of the current plus 90 because J is equal to 90. So voltage, phasor voltage is JL omega I. You need to memorize it. You need to know this to do the problem. For capacitors is, we show that V of C is phasor current divided by, maybe I write this better, J omega C. You can bring J to the numerator if you want. Multiply numerator and denominator with J, so you get negative sign because J square is negative, correct? So what is the phase angle difference between them? Theta is the angle of the current minus 90 because you have negative J, correct? So it's still the phase angle difference across voltage and current. For capacitors is 90, but here the current lead. So capacitors is says leading element, is leading element. What that means is current lead the voltage. Inductors is lagging element. Current lag the voltage by 90. Okay, so that is the summary of the what we did lecture here so far. Any question? Okay, next class, we will start from here. I need you know these things. You can read them, my note or the book. Next class, we start from here, okay? And because the key point here that you're going to see, if I use the phasor voltage, phasor current, everything we learn stay the same. Kirchhoff voltage law, Kirchhoff current law, mesh, nodal. So next class, we start from here. We use the phasors, okay? And then we will do some circuit analysis, real circuit, with the different phasor, with the different inductors, capacitors, resistors there. To answer some of your question on the chat, you will see next class when, yes, the phase angle can change, because if I have resistors and inductors and capacitors in series, then the phase angle difference between voltage and current across those three elements, the phase angle difference is not just 90. That is just for inductors, for capacitor. If I have some more element, I need to calculate it, which next class answer your question. Okay, any question for me before I close the meeting? So you're going to submit all of your homework to Titanium, please, because it seems for my grader is easier. So I have the Titanium open for you, I think, until 1 o'clock. So please go and submit to Titanium. Sorry that you did twice. If you see quiz 4, I will go and change it now if I have time. If not, don't worry, just go submit it, okay? Question for me?
Professor,
Yes.
what about the next homework? When will it be due?
After this, just doing Titanium. The next homework I says is not due until next, maybe next next Tuesday or Thursday. I let you know on Thursday. Okay. Okay. Any other question? Okay. Stay safe. I'm going to end it. Bye.